Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement and concrete industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA, and your host on the Clinker Factor. So today I'm talking to Herb Burton, who's the general manager of Central Concrete, a subsidiary of US Concrete and one of the largest producers of concrete in the US. And US Concrete have been doing a lot of interesting things in terms of looking at how we can reduce the carbon footprint of concrete. So Herb, welcome. Can you start by giving us a brief introduction to yourself and how you ended up in the concrete industry?
Yeah, my name's Herb Burton. I'm the Regional Vice President and General Manager for US Concrete. I've been with US Concrete since it was founded in 1999. I got into the ready-mix business like most people that I know of in the ready-mix business here in California, as my grandfather was in the ready-mix business. My uncles were in the ready-mix business. And so when I got out of the military in 1995, I entered into the ready-mix business and been doing it ever since. It's an exciting business. We really find it to be a business with a lot of opportunities and a lot of challenges every day. So it keeps it exciting.
Yeah, and in California, we hear a lot about the zero carbon pledges from tech companies, and California having a different policy from the rest of the US in terms of climate change and sustainability more generally. So what are you seeing in terms of demand for low or zero carbon concrete?
What we're seeing now is a very steep ramp up in demand. A few years ago, going back 2 to 5 years ago, it was low carbon was nice to have if it didn't impact cost. It was really cost driven. If you could do a lower carbon version and still meet the construction schedule, you could, obviously owners and architects would entertain low carbon. Now, what we're seeing is it's going from nice to have to absolutely have to have. And the demand's coming from owners, architects, engineers, and regulators, state regulators, all looking at this. And what you're seeing is a push to find the lowest carbon materials in the built environment. And it's really being driven by a lot of different factors, but now they're starting to set benchmarks and specifications for carbon, percent reductions, minimum replacements of cement maximums. There's a lot of different ways it's being specified. And a lot of that's being driven out of the SE 2050. It's a pledge that structural engineering firms in our market have signed on to reduce the embodied carbon in the built environment and have a path to net zero embodied carbon in structural systems by 2050. So with these different pledges and more progressive owners in the market, especially in California with high tech is very progressive, and they like to push the sustainability side. You're just seeing a big push now and really a lot of people asking the question, how do we do this? How do we do this and still build a safe building within our budget and within our schedule? So it's been really exciting. The momentum, I would say, in the last 3 years has been remarkable. The momentum has really picked up.
And are you seeing that some of the customers, at least, are willing to pay a premium for a lower carbon product?
We're still seeing, obviously construction costs in California, labor and a lot of different factors, and then entitlement of projects is very expensive. So you still see cost as a factor, but yes, people are starting to say, all things being equal, I'm going to pick low carbon, but even if you're within a certain range and you can help us meet our overall goals, we're going to entertain a premium in that. But it really depends. It's project specific and it's project to project, and that's being driven by the owners and how progressive their overall goals are.
Yeah, so I wondered if you have a tech company who's committed to zero carbon, then presumably they're going to offset the carbon footprint of something they build. So if you can reduce the embodied carbon in the building, then you can also save them money in terms of the cost of their offsets. Is that something that factors into the logic in terms of how they think about that?
It does. Companies, I'll use LinkedIn, for example. They've been very, very progressive in trying to offset. As a matter of fact, Microsoft, who's the parent of LinkedIn, has been very, very vocal about going back to zero, but then also being carbon negative to reduce all the carbon that they've created since the inception of the company. So A company like that, yes, that they want to factor in as much low carbon in the building as they can because they're working to offset their previous carbon impacts along with getting to zero. So a company like that, yes, you see a very progressive approach, and they'll ask their design teams, the engineering firms, and all of their suppliers to participate in that and to really collaborate. And that's one of the things that the ready mix company has never had a chance to do before is collaborate in the design phase. We're usually really at the very end when the job's being bid, and it's usually, hey, here's the spec, bid to that spec. We don't want to do anything different but the spec, and you do that. And what we're seeing now, and what we're really excited about is the fact that we can get in the room while the project's being designed and titled and start having these conversations and start working on solutions. So when the specification comes out, it's geared towards a level playing field in the carbon space. They want everybody to try to get to the lowest carbon, and we're able to help in those designs when we can get involved early. We can be a big asset to them, and that's what we try to do is just provide, solutions. We don't really go in there and try to sell our company per se. Yes, it's US Concrete and Central Concrete trying to, establish themselves at the table, but it's not, we're trying to get ourselves spec'd in and create an uncompetitive bid environment. It's more about, here's all these different solutions within the building code. We don't use gimmicks, different like that. What we try to say is, here's your spec. Here's the carbon impact of that. If we submitted the mix designs per your specification, this is the carbon impact of that. And here's what you can do if you were able to make some allowances within your specification that would still meet the structural requirements and the durability and all of those things. But if you were able to work more towards performance, we'll show them what the potential could be with today's technology. So it's like a 3-tier, we call it a project profile. And we work with architects and engineers to show them how their spec compares to the national averages, how their spec compares to what's out there in the market with other, buildings and different things. And then lastly, what it could be with today's technology while still meeting the current building codes. We don't work outside of the building codes. Obviously, there's a risk in building, and engineers and architects, their reputation and their liability is on the line. So we try to point towards established building code methodologies, but using the most progressive ways to do that.
Right. Yeah, I mean, I think that's a very interesting topic because obviously, quite rightly, the building codes are pretty conservative. We don't want our buildings falling down. But at the same time, it also limits what can be done. So in terms of how you design your concrete mixes, what kinds of things are you able to do to reduce the carbon footprint of the concrete?
Well, there's multiple factors. One of them is with supplementary cementitious materials. Obviously, that's the easiest go-to. There's established materials out there such as fly ash, slag, silica fume, metakaolin, different products that you can use to reduce the total cement in the mix. The total cementitious may remain the same, but you can reduce the percentage of that cement. Using high performance aggregates that have a higher strength factor, PSI per pound, that allows you to also reduce cement in the mix design. And then also using new technologies like recycled CO2, like with carbon cure. And then one of them we look at that I don't know if everybody looks at is we look at our standard deviation and our overall production quality. And if we can lower our standard deviations, the building code allows us then to lower over design, which then we can reduce cement that way. So there's multiple ways to skin the cat. And I think and one of the things you have to realize when you're making concrete is it's very localized. Aggregates in certain markets are very different. So what could be done in San Francisco may not be able to be done in Bakersfield, California. But that doesn't mean they can't do low carbon. They just have to work around the material sets they have to achieve these goals. And that takes research, and it does take some effort to understand your local materials and educate the design community that it's not a one-size-fits-all approach. It really is project-specific, and it does take collaboration with the local to understand the local supply chains.
So in addition to the cementitious, the aggregates, are there other things that you've thought about? I mean, I see that in the UK market, we've had some concrete that's been made with a geopolymer solution. Is that something that's being looked at in your market?
Yes, and we've done research with activated slag and using geopolymers and activated materials to zero cement concrete. We've done it. Some of those methodologies are not scalable, we found in our market. And what I mean by that is, the finishers and the people, putting in the activators and different things need to be trained, because some of them are caustic. We know, vapors that are maybe hazardous, or how you finish and place that concrete could be very different. So yeah, it's possible. The problem we run into so far is scalability, and economies of scale have been a challenge for that type of material. Very promising and exciting. I know in Australia, there was a runway done with no cement. So there's stuff going on all over the world trying to do different things. It really comes down to, is it scalable in your market? And is it feasible to meet your safety standards in your construction? And is there building code and structural elements and durability factors that you can meet in a structure that's being designed to last 50 to 100 years? Those are the things that you have to take into account. We like to keep it as simple as possible, because when we can engage and we aren't asking firms to make a huge leap to something they're not comfortable with, and we can work within the current building codes and the current materials that are available, there's an ease on getting that conversation going and a comfort level, because we're not, trying to reinvent the wheel with them. We're just saying, it's the same thing, but have you looked at it from this angle? And that approach seems to create better buy-in and better collaboration, because it's coming from a safer place, in the sense that their risk profile is mitigated tremendously when they can use standard materials in a different way and still achieve the same results.
So do you see a difference with public bodies like the airports or railways or road authorities in terms of a willingness to try different things, for example, to try something that might be outside the standards because they have a different sort of risk profile?
With the state agencies, they're much more conservative, so they will take more steps to research and prove out. For instance, Caltrans, which is the state agency that does the Department of Transportation, handles all the roads and bridges and infrastructure that way, they're going to be approving this year Type 1L cement, a C595 cement. It was never approved in the state of California. So without it being approved by the state, it's hard to drive it commercially, because most ready-mix plants aren't set up to carry multiple cement products. So they're limited on capacities. And, although there's a lot more vertically integrated multinational companies or larger publicly traded companies in the space, there's still a large amount of single plant operators, or 2 or 3 plant operator, and they're doing the same work we are. So they just don't have the capacity to do some of those things. So they won't switch, and they won't carry a separate cement to do state work and try to do something different commercially, because it's low carbon. So the state specifications really drive the acceptance of new products into the market. If the state of California approves it on roads and bridges, then you'll see it become widely used. I fully expect Type 1L cement to be the cement of choice in California once it's in the DOT specification, because that barrier is now broken. Now a concrete producer can carry that one cement and meet all the project specifications that they may come across. And in a ready-mix plant, you can have, for us, we have 10,000 mix designs. So you're using the same set of ingredients to make many different combinations. So it's really critical that the playing with stuff that you can use in all different forms, whether it's OSHPOD, which is this dams and hospitals, or DSA, which is the schools, and then you have Caltrans, which is our roads and bridges. So in California, those 3 agencies accepting something, and usually the Caltrans one drives those. Once they're accepting of them, then you can use that for anything. And it doesn't move as fast as we would like, but we understandably so. There's a public safety thing here. We would like to see better collaboration at the federal level. Like while Caltrans was doing their study, 1L cement was already accepted by 35 other DOTs in the United States. But yet, because of the localized markets and the localized materials and the localized soil conditions and everything else, each state is very conservative and wants to do their own testing, which makes sense, but it does slow the process down because of that. That collaboration isn't like, if it's okay in Colorado, it doesn't automatically make it okay in California. So we run into that. And that's a challenge when you're trying to advance at the speed of things are advancing now. Our industry just does not have the capacity to advance as fast. We want to, but we have trouble getting there.
So if you look forward at the future prospects for low carbon or zero carbon concrete, other than the standards and the natural conservatism of the various regulators, what are the other things that concern you or that you think will be limiting to the development of the market?
I think getting these newer technologies to market so that they can start working on economies of scale. There was a company that was making cement from CO2 called Calera in California. And, what hurt them is, it was a very expensive ton of cement. It was made from carbon. It was a recycled cement and it performed very well, but it was expensive to make. We need projects to pilot it and start doing it so then we can work on, and everything gets better if we can do it at scale. If we can start doing it consistently and not on a batch process, then you can do more. And that's the challenge. There's a lot of great new technologies out there. I'm sure you've talked to a bunch. Carbon Cure's one, Blue Planet's doing aggregate coated from CO2. And then they're also making pure limestone aggregate from CO2. And then all these are very exciting, but getting them out there, getting people to say, yes, we want to use it, being willing to pay that extra premium at first to help it get to market. And that takes a collaboration from owners and designers and from the vendors that are making the material and the producers' willingness to use them. And you realize there's so many stakeholders involved to be successful. Just because US Concrete has an idea and wants to go do it, we still need customers that will do it and use it and get their product, get the finished product they desire and meet their schedule. We need designers and architects who are willing to spec it. And we need vendors that can have a supply chain to supply it. There's a lot of pieces there. And if you're not considering each one of those along the way, it creates a lot of challenges when you're trying to do something innovative or new. But there's a lot of great stuff coming out. Our research lab based in San Jose, California, which is ran by Alana Gazetta, we get to see a lot of new stuff coming out all the time. Because of our desire to do it and us being vocal about low carbon, a lot of opportunities come our way for us to look at. So we get to touch it and play with it in that lab and really vet it out. And we take that very seriously. We don't want to create undue risk for our clients. So, like with Carbon Cure, we vetted it ourselves for almost a year before we went live with it. But now we're using it in 10 facilities and hundreds of thousands of yards very successfully. But we like to really understand the properties before we go out into the production side of it.
I think that's very critical, and I think the point that you made about these new technologies needing larger demonstration opportunities is very important. We've got examples of startups that have had a small pilot unit that they've been able to make successful in a particular location, and we need to find other opportunities, other geographies where the economics work well enough that we can get started with proving some of these technologies. And I think that's a challenge for the whole industry worldwide. And I hope that some of the people listening will take me up on this challenge and try and find opportunities to pilot new technologies.
And we're starting to see that now. We're starting to see large, whether it be cement multinationals or aggregate multinational companies, and starting to say, the world's going this way, and they're starting to invest in these small startups rather than the startups trying to, hoe the road alone. They're getting to plug into larger investments. I know Mitsubishi has an arm that invests in new technologies, and they kind of like venture capital funding. They're trying to help these new technologies get to market to help drive these things forward and push them forward. And money talks. These guys need sponsors. They need sponsors to help them to invest in them. And seeing companies like, Knife River recently invested in Blue Planet. That was a public announcement. And seeing these, more traditional ready mix and aggregate material supply companies starting to invest in these newer technologies and partner with these startups is very exciting, because that's what they need. That little kick in that deep industry knowledge. Some of these startups have an idea, but they don't actually have the real world industry knowledge, and getting married up with a large company like that that's willing to help them will get them to scale much quicker. And you'll see a much rapid uptake now of these technologies, I think, in the future. And it's exciting. It's exciting to see that more than just research, academia, but now you're seeing, the commercial sectors investing in these ideas and realizing it's necessary. It's necessary that new technology is going to have to come into the space if we're going to meet these aggressive goals that are being set out there today.
Yeah, and I think that in the concrete part of the industry, you're seeing the demand for this a little bit more direct. Your customers and their customers are asking for greener products and lower carbon products. Is this a way you think that that concrete companies will accelerate that, or do you think it's going to be reliant on the cement majors to push that forward?
I think the cement majors are going to have to be a partner in this. Portland cement, it does get a bad rap, right? You hear about it, and rightfully, it's energy intensive. It's very energy intensive to make it, and that's fine. But you're not going to build a bridge across the bay in San Francisco without concrete. You're not going to build a high rise in downtown without concrete. It's necessary. It's what makes industrialized nations. It brings us into the 21st century when you have infrastructure, and those infrastructures depend on concrete. So the cement majors are trying to do the right thing. They're going to need help, whether it be subsidizing on the back end some of these major capital projects to get their plants up to do these new technologies. These plants are built to make cement one way, and they make it really good that way, and they're very productive. And they've gotten better about emissions and all those things through regulation and through commitments from these companies. But it still costs a lot of money, and the return on capital has to be there. And so partnering with the government, whether at the state, local, or federal level, to help drive some of this. There's a lot of good work being done there on creating a low carbon cement standard in the United States. That's coming and it will happen. There's talk of carbon taxes and different things to help build funding to drive the necessary capital improvements that are going to be needed, and we have to pay for it. And so it's exciting time because the conversation's happening at every level. We're involved in conversations at the federal level, the state level, and at local levels on these opportunities. And the cement companies, they want to do it. They're not in denial of what goes on. It's just they need a path forward that allows them to do it in a way that keeps them in business while doing it. And because the build material space is inherently not a high margin business. It's a high volume, low margin business. So it does need help sometimes to do these major transformational shifts. When you're talking about shifting how we do it, it's going to take a lot of different levers to be pulled.
And particularly difficult since the financial crisis, nearly 15 years ago now, the profitability of the industry has been challenged because of overcapacity and so forth. That still is an ongoing challenge, and potentially one, of course, that the trend toward lower carbon cement could exacerbate. So it is a big challenge for the cement industry in terms of how to balance the different pressures that we're facing.
And I think the biggest thing is measurement now. Transparency first. We like EPDs. I know EPDs aren't used all over the world, but in California, we use the EPD system to measure the global warming potential of our products. We have EPDs on every product we make. We've committed to that many, many years ago. We were the first to have EPDs in the nation on a scale that we do. Every mix design we make has an EPD. And what do we do that for? We do that so we can measure, we can set a baseline of what is the impact, and then we can build goals around how we reduce that. Without that transparency and everybody participating in putting their numbers in there, and that's what's been so accelerated recently is the EC3 tool. I don't know if you're familiar with the EC3 tool, where you can log in and you can compare EPDs of different building products and start it helps designers make decisions on how they want to build a structure.
Just because some of our listeners won't be familiar with EPDs, do you want to just very briefly explain what they are?
So an EPD is an environmental product declaration. It is a way to measure the carbon impacts of the products you make, and you declare those, and they're third-party verified, and they follow what's called a PCR, which is a product category rule. For each product, there's a rule set around how that's measured and how it's reported, and it takes into account if you have product-specific EPDs in your material, you can take advantage of those lower numbers if they're product-specific. But if there's not a product-specific EPD, you would use what's called the PCR. It's the level set, like the baseline level. So for cement, if you can't get an EPD from your supplier, there's a baseline level you would have to use. And what we're finding as we started measuring this is cement producers or ready-mix producers just started inputting that based on the regulations within their state. You're going to be much lower than that PCR baseline number, which helps really start driving those numbers down and gets to really what's going on in the market, right? If you're using all those baseline numbers, you don't have a real idea of exactly what's going on in that localized market. EPDs are flawed. They're not perfect because they're cradle to gate. They're not a full life cycle, which, when you're looking at cement and concrete, the full life cycle actually benefits us if we measured it all the way through, because concrete can be reused. There's so many different repurposing, reusing, and that long service life for the amount of embodied carbon. When you dilute it over all those years, it's a pretty sustainable product on its own. And getting that education out there, but also getting the education out there that if we start measuring this consistently across our industry and everybody participates, we really can start driving the numbers down, because you don't know where you're at until you measure. And just like in anything, if you're a producer, you want to measure your efficiencies in your production process. And it's the same thing with measuring carbon. You need to have a baseline to start from, and you need to have honest conversation of where you really are. So getting all that out there will allow you then to understand, if I pull this lever, it's going to have this impact. And you can't do that without a measurement system. So EPDs is widely accepted in the United States. It's what we use. And so we've been committed to that process. I'm sure over time, it's going to evolve into something much more like a full life cycle LCA and all those different things. But right now, an EPD is the best we have. So we try to maximize the use of that tool within U.S. Concrete's footprint.
I think the acceptance of preferably international standards to measure the concrete carbon footprint, ideally including the reinforcing steel, is something that would help to move the market forward. And standardization is a bit of a boring subject, but it's really critical to getting things done.
Well, you have to have the rules of engagement in anything, and the standards do that for us. And yes, it is boring and it's tedious when you're trying to develop them. And there's a lot of back and forth about, well, is this measurement being fair to our industry versus and creating an advantage for another industry? And having said all that, yes, all of that exists. It may not be 100% fair to each industry, but get in and participate. And then we can start making change, because if you're in it, then you can have input on how we make change and move it forward. So I think sometimes we just have to accept this is where we are now, and this is good enough. And then we can start driving towards better in the future. But it takes everybody be willing to participate. And it's not a perfect system, though. No standard is. But an international standard would be better, because right now the European standard is not measured and being used in the United States. Canada has a different standard. So when you start doing that, people can cherry pick the standard that suits their product the best, and that allows for some it allows for some holes in the system that could create blind spots where people can get things can happen that may not be 100% on the up and up. I think for us, we have seen specifications now starting to come out where they look at global warming potential. It's part of the design. San Francisco Airport, everybody talks about that one, but they did a project where part of the bid was you had to state your global warming potential of your products. And they set limits on that. So you had to bid to an emission standard. That was one of the specifications, rather than just the PSI of the concrete and the water cement ratio and all the standard things we look, MOE and all those things. Now you're looking at that being a specification that has to be designed to. And it was an exciting project. So we were able to really be aggressive and progressive with how we did it. And the customer at San Francisco Airport at the time for their terminal had a very progressive carbon goals, and they wanted to see what could we do together if we all we all worked together towards it. And it was a great success. And I think there'll be a lot more of those projects in the future. But I think the private sector is going to push it faster than the public sector can. And so we spend most of our time, we do participate in the public sector committees, but we spend a lot of our time collaborating, educating, and working with architects, engineers, and owners, because we find that when we really can listen to them and understand their goals, we can find a way to do that also meets our contractors' expectations. Because people always think you have to sacrifice something for low carbon, whether it's schedule or cost. And that's not necessarily if you can get everybody in the room and have that talk and get everybody's goals on the table, you may have to play with where the carbon cuts are happening and all those different things, but you can meet the overall goal and meet the schedule. And there's a lot of great new technologies out there to help that, whether it's maturity sensors now. Maturity technologies come a long way. Measuring in situ strength rather than using the standard cylinders and test methods and flex beams is a much more accurate way to measure that for product schedule and for product schedule and construction schedule. The technologies like that, because it's come, used to have wires coming out of the slab. Now it's all digital, Bluetooth. You can, there's an app to pull the strength right out of the sensor. It's becoming so easy that it's a no-brainer. Why aren't we doing these things? Why aren't we looking at the whole thing in every way?
This collaboration is something that we've talked about in the industry for 20 years or more, and it's really good to see that it's actually happening, because it clearly has the potential to improve and optimize the usage of materials, and that in its turn will have an impact on the carbon footprint.
I think that every producer can do low carbon concrete. We don't think it should be thought of as a big shift and a scary word. We think that a lot of people are doing it, don't even know it. I think I would encourage every producer to take a look, measure where they're at, and they may find they have more to offer than they think right now, let alone pulling the levers on the new technology and all of that, that if they just told the story of all the things they're trying to do, that they can drive a lot of change in the market. And it shouldn't be something that we run from. It's not construction's evolved, for the last millennium. And we've been building stuff for a long time all over the world, and technology's been evolving. It's always going to evolve. And change is not a scary thing with the tech. We have so many ways to measure now. We know more about a yard of concrete we batch now than we've ever had before. We know everything. We can predict what it's going to do. As soon as it's batched, I can look at that batch ticket and tell you how that concrete is going to perform. And that's not a huge leap. It's just rolling your sleeves up, measuring, starting to tell your story, and really going out and trying to engage with architects, engineers, and owners, and spend the time to listen and share ideas. Ready-mix producers have a lot to offer. They need to try to get upstream and really get in those rooms, and bring in the cement associations and their cement producers. Collaboration is key. And I guess that's, if I was going to end on anything, I would say we need to continue to collaborate, and we need to make it, instead of that one-off here and there, that needs to be the standard when you build a building. All stakeholders should be in the room. We should be collaborating on that.
Well, I certainly agree with that. So I think that's a wonderful note to end it on. Thank you very much for talking to me today.
Thank you, Ian.